So official with the podium and mic. Thanks so much, Em. Yeah, I'm shorty. But down here to 5, 2. It's better. You can go up when it's your turn. So thanks so much for joining. As I said, my name is Gail. I work at the Gulf of Maine Research Institute with our Community Climate Action team. I'm just going to introduce my colleagues before we kind of like dive into the rest of the evening.
Hi, I'm Evan. I'm also on the Community Climate Action team. I'm an AmeriCorps fellow.
I'm so sorry. I don't know how that happened.
Celebrating Evan.
Okay, I think we're good.
Right.
Okay. You're good. Yeah, I'm stationed at the Gulf of Maine Research Institute on the Community Climate Action team. So I'll be presenting along with Gail today.
Hi everybody, my name is Sienna Zuko and I'm the Climate Services Project Manager with the Gulf of Maine Research Institute, also supporting the Community Climate Action team. I won't necessarily be presenting today, but I'll be here.
Great, thanks all. And then just a note too, great, Emma's watching for the chat for questions online, but also really, we don't want to be talking at you for the next like 40 minutes. So if you do have any questions throughout, especially as we go through data, you want to chat about something, like please feel free to raise your hand, or if you see any like relevant questions in the chat, please do interrupt. We can keep this like pretty informal. So I'm just going to do a quick little intro and then I'll pass things over to Evan, who will be diving into like the science of sea level rise. I think we've got a little bit of back and forth in there, and we'll be sharing about community science, and then I'll wrap it up with sharing about some kind of future projects that we have going along in Rockland, alongside with Jenny, who's with the sustainability department at the city of Rockland. Great. And all right, cool. I'm not familiar with PCs, but that worked. So I really like to start presentations around talking about sea level rise off with actually this specific photo, because this is a place that matters to me. This is my local beach and my kids enjoying it. They're much larger than that now. This photo is about 10 years old. But this is the reason why I like to start off with a place that matters to me, is because I hope that in doing that, it makes you all think about what is a coastal place that matters to you. So kind of envision that place. And as we're talking about coastal climate impacts, we're going to see these locations change over time. And those changes are going to evoke a whole array of emotions and have a whole array of impacts to us in different ways, as well as our like neighbors. And some of it might be really personal, around personal property, or like just thinking about places that you care about and watching them change and look so differently over time, or even thinking about the ecosystem and the species that rely on these locations. And I just want to invite and create a safe space for sharing those emotions as we kind of dive into the data today. Because as we kind of tackle climate planning, we're not just planning for like infrastructure and looking at graphs, like we're really planning for how can we be people and communities living and thriving in these places. And so that means that we really need to talk about what is it that we want, what matters to us, how does that make us feel? So just want to invite that into this evening's conversation. I also think it's great to start with looking at a photo too, because as we look at places that we care about, kind of noted change over time, you can see evidence of change as you're out there making observations. So as you look at this photo, what are some clues as to how this location may be changing? What do you notice about it? Yeah. Very little beach. Yeah, great. What else?
Seaweed washed right up to the weeds.
Great. Yeah, seaweed is washed all the way up to the weeds. Great. Any other observations?
It's
Yep.
very flat, so it wouldn't take much for that if any rise at all to continue along further stream.
Great. Okay, so like flat land, kind of vulnerable to future or for flooding, for water to reach in. Great. Cool. All right, thank you for sharing those. So from these observations, we can see that the prior high tide was quite high. It was all the way up to that seagrass, that dune grass, and maybe even perhaps beyond. And so we're seeing more of these frequent high tides over time, and also seeing flooding in places where we don't expect water to be. during storm events that are happening what seems more frequently, but these storms may have been happening all along, just they're happening during these like high water events, which means that there's kind of more risk for a smaller storm to have like a big impact, or for us to feel that impact from it, because we are in this high tide zone a little bit more as a state, so more vulnerable there. Great. So just keep that in mind as you're like going out to the places that you care about, that we can make lots of observations and kind of note what are the environmental conditions and how are those changing based off of kind of the events that are there. All right, so to hop into a little bit about the Gulf of Maine Research Institute, our kind of place of office is on Commercial Street in Portland. If you're familiar with Becky's being a landmark, we're right next door. We do work statewide as well as throughout the Gulf of Maine, and some of our programs are national and even international, particularly in the fisheries research space. As an organization, we really strive to develop and deliver collaborative solutions to global ocean challenges. So I just kind of noted there, a lot of our research work is focused on the fisheries space, and our community work is with coastal communities throughout the state and beyond, to really kind of bridge that gap of understanding what's happening in our oceans and how that's going to impact us as coastal communities. And we really do that in an intergenerational way by engaging youth in a meaningful way along that. But thinking about global ocean challenges, climate is really like the key challenge that we're all trying to understand and also prepare towards what the projections of climate change will be. Thinking about our ocean environment, we've got rising seas, which is what we'll be exploring tonight, but it's also warming, it's becoming more acidic, and the kind of ocean patterns are changing, which are going to lead to other impacts as well, particularly shift in perhaps weather events. So to not start on thinking about all of the like impacts of climate, but as we're planning for climate, we can also think about not just planning for what those impacts are, but planning for what we want our communities to be. So if we think about climate change, what is it that we want our communities to be under those conditions in a way that we're still thriving here as coastal communities? What do those communities then look like? So underneath those changes, how do we like maintain sustainable fisheries? How do we make sure that our infrastructure is going to be resilient? Those coastal zones and that environment will be healthy. How do we still maintain our like sense of place as being a coastal community, and how do we do this in a way that is just and equitable for those who are going to be most impacted by climate change as well? So thinking about how do we not just adapt to climate change, but take that opportunity in change to grow and really become thriving communities. So that's what we're like planning towards, but the data part is also important because that lets us know what we're planning for. So on that, I'm going to pass things over to Evan, who's going to dive into some of the sea level data.
Yes, thank you, Gail.
Thanks, Jenny.
Perfect, yeah, so I'm gonna first talk about the science of sea level rise and how it's impacting the coast of Maine and Rockland specifically, and then start talking about what are some things that we can do about it. So first, to understand the problem, you can see here on the left showing a graph of sea level, annual mean sea level over time. Clearly the trend is increasing, as many people probably already know. The reason for that, though, is twofold based on climate change. The first is that global warming is causing melting of land, snow, and ice, which turns into water, trickles into the ocean, pretty much adds water to the ocean that wasn't already there before, causing the ocean to grow, essentially. And the second is a scientific principle called thermal expansion, which pretty much states that when matter gets hotter, it expands. So global warming is causing the water in the ocean to physically get bigger and causing our tides to rise. So you can see in this graph over to the right that shows global contributions to sea level rise. These three columns here are all the melting of land, snow, and ice, and then this one is thermal expansion. So these are what climate change is causing, or how climate change is causing sea level rise. Then we are also situated in a pretty unique position geographically alongside the Gulf of Maine. that causes us to experience the effects of global ocean changes in a more extreme way than other parts of the world might. You might already know, the Gulf of Maine is one of the fastest warming bodies of water on the planet. It is warming at a rate that is 3 times faster than the global ocean average. And the reason for that is, there's a few reasons. The first is that the Gulf of Maine is relatively shallow, so it doesn't require as much heat input in order to warm up faster. The second is that climate change is causing a major disruption to a lot of global ocean currents, and the Gulf of Maine is fed by 2 main ocean currents, the Gulf Stream, which brings warm water up to us from the tropics, and the Labrador Current, which brings cold water down to us from the Arctic. And climate change is increasing the input of the Gulf Stream to the Gulf of Maine, so adding more warm water, and decreasing the input of the Labrador Current to the Gulf of Maine, decreasing the input of cold water. So pretty much turning up the hot water faucet and turning down the cold water faucet. On top of that, not now, but in the future, the Gulf of Maine is going to experience a disproportionately faster rate of sea level rise compared to other parts of the world. This graph, or this map, shows you what areas of the world water is going to move when Antarctic ice sheets melt. Up to this point, there hasn't been too much substantial melting of the ice sheets in Antarctica, but when they do melt, the way that that's going to impact like gravitational forces is going to pool water in these dark red zones. So here and here around the east and west coast of the United States. And scientists have been referring to this as the bullseye of karma, which is a little comical, a little sad, but it's karmic because, the US has been disproportionately contributing to the perpetuation of climate change. And in the future, sea level rise due to Antarctic ice sheet melting is going to cause us to bear the brunt of some of that coastal change. Yes?
The numbers on the right, are they feet or meters or?
Okay, good question. So this is actually like a statistical bar. I was talking to scientists at GMRI, and they were saying that like it has to do with standard deviation, how far away it is from the mean. So 0 is kind of the mean at wherever point on the map you're looking at, the average, whatever that is. If it's higher or lower than the average, then it changes color. So it's pretty much, yeah, the red is like how much above the mean sea level would be.
Yeah, I still don't understand what the numbers mean.
So you can just think of it sort of as like a relative sea level to current levels. It's not an exact measurement, it's just an estimate of how much is going to change.
Are we gonna see any,
Yeah, kind of like a percent. Or were you going to say something in the back?
are we gonna see any of those actual rise measurements later?
Yeah, not based on like the whole map, but yes, kind of projection and timeline wise. I'll show you some data about how sea level is going to change in the future. Yeah, actually on this slide, I can get into that right now. So yeah, it can be pretty scary to think about the fact that Maine is going to be experiencing changes of the ocean at a more extreme way than other places around the world, but it does offer us the unique opportunity to become trailblazers in that sense and really set a good example for how we can best prepare and respond to these events. So in order to do that, luckily we have the power of science at our disposal to be able to allow us to glimpse the future a little bit and really understand the problem that we face in order to set plans for how to address it. So we have projection graphs like this that show you the first part. This black line shows us the actual observed sea level over the past 100 years, which you can see amounts to about an 8-inch increase in the sea level. And then the graph opens up this part because the future is largely uncertain. Sea level and what it's going to look like largely depends on whatever actions we take to curb our carbon emissions today. So these dotted lines represent the outer boundaries of where we can expect sea level rise to fall within. This dotted line shows a high carbon emission scenario. So it's pretty much business as usual. If we just continue emitting a lot of carbon to the atmosphere, that is the highest that sea levels will rise. The blue range follows an intermediate carbon emissions scenario. So if we don't take any actions to drastically increase or decrease our carbon emissions, sea level rise is going to fall within that zone. It's a pretty likely scenario to happen. And decision makers can use data like this in order to set targets for what we should prepare to plan for. So the state of Maine, in our statewide climate action plan, Maine Won't Wait, has used this data to set 2 different preparation targets. One is called commit to manage targets, one is called prepare to manage targets. And they're just targets based on 2 different carbon emission scenarios. So the first, which is already overlaid on this graph, these black dots here, show the commit to manage targets, which are set at 1.5 feet in 2050 and 4 feet in 2100. So you can see they fall right along the upper edge of the intermediate carbon emission scenario. And so these targets can really help us prepare for infrastructure that can maybe experience some water damage. So maybe more floodable spaces like parks and maybe non-essential roads. But when we look at these targets, the prepare to manage targets, these are suited more for spaces and infrastructure that cannot really withstand any amount of water damage. So like emergency shelters, hospitals, like evacuation routes, stuff like that. So these targets, as you can see, fall along the high carbon emission scenario. So they're set at 3 feet in 2070 and 8.8 feet in the 2120s. And in setting these targets, we aren't saying that these amounts of sea level rise are going to happen, but we are preparing for the event that they do, just in case. We also have at our disposal maps overlaying projections of sea level rise. And this is the coastline of Rockland. This shows us, so blue is the ocean, but then these bits of green here are where the sea level is going to overlap on the land. And this is for 1.5 feet of sea level rise, which if I go back here is the first commit to manage target for 2050. So that's what that would look like. Then if we increase it to 4 feet of sea level rise, there's more of these spaces that are colored green. And then 8.8 feet of sea level rise, that's the 2120s prepare to manage target. But I will note that these projection maps have some inaccuracies because the way that they are made is following bathtub models, which pretty much just is like imagining a flat raise in ocean on top of land. So anywhere on the land that is at an elevation lower than this tide height gets colored in green. But we obviously do not live in a bathtub, so water does not really behave that way. Water gets moved around by weather and wind and storms and all these other forces, so it's not going to be as clear cut as just looking at this. On top of that, those bathtub models don't account for other factors like storm surge, waves, tides. So I can also back up. This chart shows you different factors that can impact sea level. So the darker blue arrows are showing like what can contribute to higher levels of the sea, and then the red arrows show you like decreases in ocean height. And there's kind of some variation in like the size of these arrows because we don't know, or there's a lot of inherent uncertainty that lies within predicting the future. But this is just to show you an example of all the other factors at play in determining sea level height and why those bathtub models aren't actually the most accurate tools for us to use in planning. Yes.
Has any perturbations in the AMOC been taken into consideration in putting these together?
I'm not sure I've heard of the AMOC.
Yeah, I can take it.
Yeah.
Yeah, sure. I can do that. So it was around how like ocean currents, I'm just going to make it kind of broad, are taken into account when we're thinking about sea level height, sea level change. One thing that we did see over kind of the past few years is a higher sea level than what was like predicted. So consistently in 2023 and 2024, sea level was anywhere from like 2 inches to a foot higher than what was like predicted almost year round. In part, that's like what led to some really like bad storms in January of 2024. We had just like a higher sea level on average. The exact science as to why that happened it'll take us a little bit to untangle that. But the prediction is that it was likely due to ocean currents, because we saw something really similar happen in, it was 2010 or 2012. Sorry, I'm like trying to picture the chart. Yeah. Where in the Gulf of Maine, on average over the course of the whole year, there was 5 inches of water more than what was predicted. And that was due to the ocean currents, kind of similar to what Evan was saying earlier about like why the Gulf of Maine is warming is because those currents are shifting. And so we're getting more like warm water in than cold water, but in part because why that warm water is coming in is that the strength of that Gulf Stream that kind of comes up and around the East Coast and shoots off into the Atlantic from Cape Cod. The strength of that is weakening, which is letting that warm water trickle in, but it's also, it used to also, that strength would pull water kind of like out of the Gulf of Maine into the North Atlantic. Since that's weakening, it's actually causing water to pool into the Gulf of Maine. So that's one way that ocean currents are having like an impact here. So we're still unsure if those currents are what was causing the higher sea level in 2023 and 2024. We'll probably know in a couple of years, but yeah, great question on that.
This is kind of like a base level. It's not including that raised one. So the raised is 6 inches, but then the storms also bring more. Right? I just know I spent a lot of time on the side of it, but it's now super flooding. And that's also affecting the rivers too. So is there any, you're looking at posts, right? You're looking at
Yeah. Do you want me to keep going? You got that?
You can keep going into
Okay.
the next slide. Is yours
Yeah, it's on
anyway.
there. I'm here anyways. Yeah. Good question for a transition anyways. Yeah, so like kind of like this slide shows, there's like a lot of factors that go into like the actual height that you're looking at, and sea level is a small factor right now with the potential to be really great. You can see river flow on here is really great. This is a space where there's a little bit of a black box and a lot of opportunity to really understand, and particularly in Maine, I think that's a place where we can really dive in because we have these really large tidal river systems. And yeah, as you noted, we're having a lot more extreme precipitation events. And if you know anybody inland, particularly like that December of 2023 storm that hit, like crazy rain, crazy washout. It also was really humid, and it caused a ton of snow melt. Like we oddly had snow in Maine in December, at least like up in the mountains. So a lot of water rushing down and through those tidal rivers. So USGS, United States Geological Survey, thank you, all the acronyms, it has been primarily the folks who have had the gauges in and monitoring the river flow, as well as river height. They kind of stop where fresh water gets salty. And then NOAA has been primarily monitoring the salt water, and they really stop where the water gets fresh. And so there really hasn't been that connection between the two. I think, well, yeah, I'll chat about it a little bit more in a bit, but I think the opportunity is really ripe in Maine. I think the connections are in place, the technology and the expertise is here in the state to really start to uncover that. I'll chat a bit more about that in a bit. But yeah, good question. Yeah, all right, so I'm just gonna keep flowing. Please do keep the questions coming. So we just wanted to kind of also share, like, because everyone's been talking a lot about like projection data and what we might see in the future, but I'm really curious for those of you, well, doesn't Rockland or not, how many of you have observed flooding in your community? Okay, great, a lot. Does anybody want to share any stories? Great, thanks. Yeah.
literally lost families' cottages. So
Mhm.
But it's like 20 foot, like how far do they reach these like 100 foot areas? So we definitely will be as our conservation commission, and we increased our membership by 82 months ago.
Mhm.
And what can we do? There's lots of things to be about this, but we look at schools and those really very quickly, they don't have how to exchange. So because so many people stop their own yards, they live there for generations, so they're seeing this.
Great. Yeah, yeah, great. I'm gonna like do a quick summary for folks on Zoom. Oh, sorry, I'm not gonna capture it all. But yeah, just sharing like their like experience, seeing everything from like complete kind of devastation, especially, I'm assuming that was January 2024 when like homes were washed into the sea. Maine has never experienced water level that high before, and we definitely built for water levels a lot lower than that, and think that was something that happened up and down the coast, as well as flooding during like kind of clear skies and full moons, so that kind of high tide flooding. Great. But also great to, I don't know, pros, cons, clearly we never want to experience like devastating storms like that, but it also did have that reinvigorated energy for engaging in how do we start solving this problem in communities. So it's great to hear. Any other stories to share? Is anybody typing any in the chat? You're welcome to do that too. I'll show some pictures then. So Jenny shared some photos locally from Snow Marine Park. This one's during the January 2024 storm. I'm not sure, it was the 10th or 13th. They were both really similar. They were like inches apart, but clearly a lot of flooding there. We were just down there hosting kind of a coastal meetup event to learn a little bit more about community science, which Evan will dive into in a second. And somebody who's been here, a Rockland resident for a while and really keen on history. If you see that like strip of land there, y'all used to have a trolley that ran through there. So it was a raised land, and then learned all of this is fill. So it used to be not even a marsh, it was really a tidal basin that water flowed into and out of twice a day, every day, that was filled in. And having filled spaces is so common amongst coastal communities as their kind of populations grew. And any sea level projection map, like what Evan showed you earlier, these are the places that you're going to see the water go first, is seeing the water reclaim places that we kind of already took from it. And then more recent, April 26th, y'all probably tired of the rain we've been having. This week's been really lovely and sunny. Really sorry it's not gonna be the case this weekend, but it also wasn't the case on the weekend in April during a coastal cleanup that Jenny hosted, again at Snow Marine Park. I think there was like 3 inches of rain, so extreme precipitation event. Water was like already saturated the ground that day, and so some like pooling and flooding happened there. So I think this also gets to that interesting question of really understanding like the impacts when you do have these extreme precipitation events, that weather event alongside with high tides. It wasn't high tide, you can see the kind of rock line here that day, but if it was an extreme high tide, the impacts of flooding that day could have been really different. And kind of one other kind of point to make here too, like these are like just like one spot along Maine's coastline, and we have like 5,000 plus miles of tidally influenced coastline. So there's like a lot of places to understand and variation around the state, from like 10-foot tides down in Kittery to like 20-foot tides down east, and like are you pointing out areas that are like really low, like beaches and marshes, or like some are coastal towns, to you guys are in kind of the rocky bluff or a bit of a mixture, to like rocky cliffs when you get down east. So our coastline's like different all over the place. And yeah, we only have 4 NOAA tide gauges. So understanding what that water level is on those days is really, really difficult. So we've been partnering through a couple of different grants with NERACOOS, I need to read, the Northeast Regional Association of Coastal Ocean Observing Systems. How many of you are familiar with like the ocean buoy data? Great, that's these guys. Already experts in getting technology and infrastructure out into the sea and the saltwater habitat, getting that data in and getting that into the hands of people. And ocean buoy data is really important for fishermen, for harbor masters, for surfers, to understand what those ocean conditions are. So they've been recognizing, oh, yep.
Aren't they taking the news and not returning? They used to take my food and put it back, but now they're not.
I'm unsure. Yes,
Those are now Coast Guard navigation.
yeah, there are some buoys being removed from the ocean. More around navigation, so I don't think they're the data collection ones. NERACOOS, as long as there's funding, will keep theirs in the water. Well, and then once they're out there, they're kind of self-sustaining, so as long as they don't need kind of repair or replacement, they'll stay and put. Yeah, but yeah, great question. But really, really critical data. And so they've seen, alongside with GMRI and lots of other organizations, that need for having more water level data, especially along our varied coast. So in collaboration with NERACOOS, GMRI, lots of community partners, including Herring Gut, who's here today, we've been placing water level monitors kind of up and down the coast. So you can see some of the ones that have been placed right along here. And NERACOOS is also hosting a water level viewer. So you can see what the predicted water levels were, as well as what the actual water level was. And then the bars up top are kind of highlights for like minor, moderate, major, extreme flood conditions at the site of the water level monitor. So it's not necessarily an assumption for the community, because even within one town, it can flood in one spot and not the rest. Every location has its own kind of flood threshold, which is what that is. So we've been collaborating with NERACOOS to get more of these water level monitors in place. I know there's a lot going on in this map, but just to show you all the locations that they're looking at or have been recommended to place water level monitors on their own or in partnership with organizations like GMRI. And this blue triangle is Rockland. So we're really excited to be putting a water level monitor off of the municipal pier in the very near future. It's part of a project that I'll chat about later. It's also funding these ones up and down the Kennebec River, which gets to your question about how do we understand what's happening with tidal rivers and coastal flooding. So excited to get all this data in place and talking to one another. So I think things are coming together to really kind of understand that bit. But even with all this data in hand, if you see on your tide gauge here in Rockland, oh, hey, the water level is going to be 12.5 feet today. Like, what does that mean? So that's kind of where I'm going to pass things over to Evan, and it's like kind of the role for community science is to help us understand exactly what those measurements mean within a community and where the water is.
Perfect. Thank you, Gail. So yeah, community science can really help us bridge the gap between data from physical infrastructure like NOAA tide gauges and NERACOOS tide gauges to social infrastructure like that is naturally embedded within communities. Community science is a super powerful tool. It creates a process whereby anybody can contribute quality data to professional scientific research. It creates accessible products that display the data collected to end users, and it can enhance climate literacy within participants. So I'm going to be talking about one of our community science projects at the Gulf of Maine Research Institute, the Coastal Flooding Community Science Project, which really seeks to answer the question, what water level and weather conditions lead to local flooding in communities? The reason being that, as Gail mentioned, sure, you might have a tide gauge saying that you're going to expect 14 feet, a tide that's 14 feet high, but what does that actually look like for flooding within communities? So this project can help us answer that question. So this shows you the website for this project. It's called the Ecosystem Investigation Network. It's where all the data for this project lives, and it is where you submit your data once you make an observation, and it is where you can look at past submissions of data to this project. Here in the bottom right, you can click on it, and it brings up a story map that shows you the locations of all the current monitoring sites for this project. In Rockland, there are 7, marked here in the blue pins. And monitoring sites can be anything from a park to a pier to a bridge, anywhere where we might expect to see flooding occur. They are co-developed between us and the town that we are working to get enrolled in the project based on the criteria that monitoring sites should be publicly accessible, safely accessible, and represent the diversity in flooding that we see amongst ecosystem, infrastructure, and places of value for our community. So we have 7 currently set up in Rockland that you can go to whenever you wish and contribute observations of the flooding that is or is not present at that time to this project. Sites are also marked by these signs. I think, is this one? Yes. They also look like this here. So if you ever are walking around and you see one of those, that's us. So definitely take some time, stop by, and submit some data. There is a QR code on all of them that brings you to the project page, and so you can, on your phone, follow along the data collection protocol when you're right there, and then submit the data. Your ruler? No, you do not need to bring a ruler. All the tide heights that it prompts you to estimate are based on like relative and easily visually estimatable amounts. A good question. So when you're at a monitoring site, or I guess this is after. So after you have followed along the data collection protocol, you will be asked to contribute the data on this ecosystem investigation network. You can even contribute data from sites that are experiencing flooding that aren't at monitoring sites established in this project. So anywhere you see flooding happening, you can definitely follow along the protocol, submit that over to us. You mark, you can like drag the pin here on this map, and then it automatically adjusts the latitude and longitude for where that site is. So just the caveat being that if you're contributing data from a site that's not already enrolled in this project, we collect that geographic data. So if you don't want to share us, then don't contribute that. But when you're following along the data collection protocol at a monitoring site, you'll be asked to collect a few types of data. One, you'll be asked to follow a questionnaire, a few types of questions. So it'll ask you like, where are you? What time is it? What monitoring site are you at if you are at one? Then it'll ask you about environmental conditions at the time of observation. So it'll ask you about the water level, precipitation, wind, and waves. And the purpose of this is really so that we can connect the dots between environmental conditions, tide height, and flood impact. It'll then ask you to submit your photos of the flooding that is or is not present at that time. We ask you to submit multiple photos from different angles to really fully capture the full story of flooding that's happening at that time. We also ask you to include within your photos easily identifiable landmarks. Like for example, in this one, they include the building here. So that helps us when we are geo-referencing the extent that the flood reached in the data analysis side of this project. We also ask you to include photos of evidence of past flooding events, so like rack lines like this, and erosion like that, because that can help us identify sites of high concern and really pinpoint where flooding reached at its peak. In the questionnaire, it also has questions about you and your feelings and thoughts about the flooding event that you are witnessing. It asks you like what your role in your community is, what is your level of concern. It asks you for any climate adaptation actions that you think might be particularly relevant to implement at that site. And these questions are really useful for town decision makers to hear because it can really help them identify and prioritize sites of high concern for their community. Then on the Ecosystem Investigation Network, as I mentioned, you can also view all the past submissions to this project. So here they all are in these yellow circles. In Rockland, there aren't too many right now because Rockland just got set up with this project earlier this year, but that's also a call to action for y'all to go out and submit some data. But you can filter all the data based on a few different categories, based on what you're interested in looking at. So you can filter it based on time of submission, flood severity level, the location and site where you're at, and then photo tag. So these are qualifiers that you're asked to tag your photos when you're submitting them in the first place about what is in the photo. So if you're at like a parking lot, if you are at a marsh, something like that. So then when you're looking through the data and filtering it, if you have a specific question like what did minor flooding look like at churches in Machias on January of 2024, you can set all those filters and then pull up all the pictures and submissions to that project. So this is a really useful tool that towns can also use to know about the flooding that's happening in their communities. If you then click on one of these submissions, it brings up this page, which is a visualization of flood thresholds. It's a feature of the program that we're working on fleshing out a little bit more. So this is an observation from Machias. The yellow vertical line shows the time of submission. These blue wavy lines show the tide height measured from the nearest tide gauges. So there's two tide gauges close to where this data was submitted. And then in Machias, there are 3 different flood thresholds that we have currently on the website. I checked off 2 of them, and that overlaid these black horizontal lines where those flood thresholds are in relation to tide height. So for example, the top one, the Route 1 flood threshold is set at 11.15 feet. So when the tide surpasses 11.15 feet, we expect that site to flood. The Norman Nelson Park one is set at 10.5 feet, so when the tide surpasses 10.5 feet, we expect that site to flood. And you can see at the time of this submission, marked by this green dot, the tide height, the blue line, isn't that much higher than the flood threshold for Route 1, but it still creates this amount of flooding that you see in the picture to the right. Also important to note, the tide height measured by this darker blue line is from a tide gauge further away. It's this one instead of this one, and the yellow dot here is where this data was submitted. The black dot is the tide gauge. This black dot is the further tide gauge, and it shows you that at this time point, the tide wasn't actually higher than that flood threshold, even though it clearly was. So that also just underscores the importance of installing more tide gauges, which Gail mentioned we are working on. All the data from this project gets submitted to us, and we connect it with the National Weather Service. They use it to incorporate it into their existing models and use it to develop new ones. That can help us enhance flood alerts and emergency systems, and it can also be used to inform climate decisions within municipalities. And then I'll pass it back to Gail.
Thanks, Evan. So just on Evan's note there about the National Weather Service and kind of to your question about like, do I need to go out with a ruler? Like our intent behind the protocol was to develop something as simple as possible, as easy as possible for people to just go out and do. And so we worked really closely with the National Weather Service, Maine Geological Survey, NOAA's Office of Coastal Management, as well as community members to design these questions. And the data really comes in kind of more categories. So as you use that kind of drop down from like what Evan was showing you, you have like choices to select. So as opposed to like, oh, there was 10 inches of flood water. We're not looking for that detailed data. That's not what the National Weather Service is looking for either. They want to know what minor, moderate, major flooding looks like. Well, what does that mean? So we worked with them to untangle that. So like minor flooding is, and you don't need to walk into the water, be safe, but take your best guess, like at the point of where water is reaching is minor flooding, it'd be like it touches the bottom of my shoe. Moderate would be like shin deep, and then major would be like waist deep or higher. So it's really just like your best guess around those categories. Similar for like weather, like precipitation. Well, I guess we all know if it's like raining or snowing or hailing. So those are pretty self-explanatory, but wind is a category 2. So it's like, are the tree branches just like jingling, or like, is it too windy for an umbrella? Like those are the types of like questions that you're answering. So no equipment needed, I guess, being the point, other than like a camera, which we all carry in our back pocket now. So that's cool. All right. So I'm going to pop over to just kind of share a little bit of like what's next. I'm going to pop back to this one that Evan was showing on, because I think one thing that's really cool, when we took the screenshot, we had like 608 observations to date. That's since 2020. This project started in Belfast. So that's why you can see a whole bunch there way back in 2020. Great year to like launch a project, but they embraced it and went for it. And since then, we've expanded to a lot of communities along the coast, communities that aren't even like officially enrolled in the project, such as the Conservation Commission down in Algonquin. I think there's like 51 observations there, really, really active commissions, thinking about your Owl's Head group. Not technically enrolled, but go for it. We really encourage anybody to go out and collect data to be useful. Our goal of partnering with municipalities is that they're able to inform like those site locations because that's where like they need data to make decisions, as well as we can partner with them and support some engagement and getting folks out like doing events like this. So thanks for being here. But yeah, so data's been collected a lot over time, and we've also like grown this program a lot over time. Like what Evan shared here, we just launched this a year ago, I think, this new data visualization viewer and the filtering tool, just starting to pair those water level monitors. So we're really excited to continue to grow this program, and have also like heard of a need for these data repositories through like the strategies in the Maine Won't Wait Climate Action Plan. So where we're hoping to go from here is to continue to develop new products and models, particularly that support like, hey, we've got the data, but now how do we like connect that with the decisions being made? So we just worked with a graduate student at MIXI, Maine Information Science Exchange.
Yes, something like that.
Maine. Graduate student, she was looking at the photographs that were contributed during the January 2024 storm and ground truthing those alongside with South Portland has a dynamic flood model, for example. So their model actually incorporates waves, which we will have for the whole state in hopefully a year, so we won't be stuck with the bathtub anymore. But yeah, so really ground truthing models. So it's been proven to be a really cool tool there. So we're starting to go down that path, a place that we're looking forward to continue to move. Also looking to expand, particularly up into that tidal river watershed. And we're just about to release an inland flooding protocol that was developed alongside with the Oxford County Emergency Management Association. And really looking to expand that statewide and start to pair that data to understand that where tidal and inland flood is coming together. It's like, great question. That's a place where we just don't know yet. And so I think there's like really great opportunity there. So that's where we're going. And some of the projects that we have in place that are going to help us to get there. GMRI is a partner with a project called, so many acronyms, 3CRS, or the New England Community-Driven Coastal Climate's in here twice, Research and Solutions Hub. So 3CRS, this is an NS National Science Foundation funded project. We are a partner on that project. Brown University is the lead on that project. Other partners are also, I'll pop to this and come back. University of Rhode Island, University of New Hampshire, Rhode Island College, and Syracuse, which I mentioned earlier. So it's a really large academic team with a heavy research base. This team here at GMRI is the kind of outreach and engagement portion of this work. And as a team, we're really striving to understand when we're looking at those like climate projections, like what are those tipping points in those projections where you're going to see those impacts to health and well-being of communities within a working waterfront context. So we're working alongside with 4 focal communities, 2 in Rhode Island, Port of Providence and Port of Galilee, and 2 in Maine, Rockland and Bath. So we're really excited to be able to bring the research expertise of this really broad, gnarly academic team. If you've been part of a large academic project before, you kind of have a sense of that. But to bring that set of expertise in to help support like the questions that the city has and the data that they need to support your kind of climate resilience goals. And then as a team, or as the research team, they're also looking to like, well, how do we then kind of scale up that work so we can create some shared models that will work for other coastal working waterfront communities.
Question.
Yeah.
How's the funding for that?
Yeah, great question. We're wrapping up year 2 of the project. Year 3, we just received from NSF an optimistic nod that you'll get money in hands for year 3. But as you know, it's kind of a like day-to-day, week-by-week landscape out there. Our principal investigator on the project at Brown University is optimistic. I think he's optimistic by nature as well. But we have year 2 kind of like funds in hand, and have already been in conversation with Jenny around like, if this is all we have, what can we do that's useful? So I'll chat a bit about the timeline of the project and what we'll do and what we hope to do, I guess. So that's kind of where it is, yeah. So some of the kind of capacities of this team and kind of divided into 2 bits. The blue side is the technical expertise, where they can really downscale climate models to be really localized and create data-driven products. There's AI expertise, as well as tap into like a wide network of experts that this group has that we can bring in. So if there's any questions that arise, feel free to filter them up through Jenny to me, and we'll tap you through to this expert team. So it's kind of access to that like whole encyclopedia of knowledge that these folks have. The red ones are more on the social science side of the house, which, in my opinion, social science has been left out of the conversation of how do we adapt to climate change. And it's fortunately really being started to roll in, and really, really excited that capacity is part of this team. And some of that questions that team is looking at is place attachment, and how does our perception of place influence how we make decisions about that place? And then what does that look like when that place is changing? So that information will help design projects and programs for community outreach, as well as really help get community input so that projects that are developed are community driven, which I know is a value of Rockland. We're also doing a lot of outreach and training, which is like what we're bringing into the project. The coastal flood monitoring sites are a piece of that. And we've already started to reach out to some of the local teachers to get youth involved in that project too. And then if we get to year 4 of the project, we'll also be taking all of the data products and tools and research papers that come from the academic side of the house and developing these crosswalk or resource materials to make that academic pieces accessible to people who would find that data useful, so decision makers. So thinking about tools and resources and training that can accompany those papers and data tools. So the challenge 1, 2, 3 here is kind of the flow of how we're breaking up, thinking about diving deeper into the project. So we're in this space right now where we're like identifying and measuring changes in human health and well-being, habitability, environment, and other climate vulnerabilities within communities. The team is working already towards downscaling those climate models. A really neat tool out of University of Rhode Island. It's called CHAMP, Coastal Hazards. I have it written out on this one. Coastal hazards, no I don't, I wrote it out on something else yesterday. Analysis and it's a downscaled model. Thanks. It's a really cool tool for doing property level, utility level assessments. So thinking about, all right, well, if you head down to the municipal pier, where are like any like electrical outlets, where are kind of your entry points on or off, what are the elevations of all of these, or thinking about like the harbor masters, home down in Harbor Park, what are the sill levels of the windows, of the door frames, and then creating like a 3D model. So, and then putting that model into another model that can bring in weather and storms. And so if the National Weather Service is predicting like, say, 3 feet of storm surge coming from the northeast at XYZ tide, they can run the model 48 hours out once we get that weather alert, and then they can say, oh, here's the points of failure and what that failure then means for the property, and get that into the hands of the person who can then prepare that property. So really thinking about like near-term disaster preparedness. It's a really cool tool for that. So we're bringing that into Rockland and Bath through this project. So that will happen. Yeah.
Who's the PI on that project?
Manu Emmanuel. He's at Brown University. Sure.
I think Di Lorenzo.
Oh, Di Lorenzo. Thank you. Yeah. Emmanuel is his first name. We call him Manu. That's why that was in my head. Yeah. Emmanuel Di Lorenzo. So right up here. University of Rhode Island, the CHAMP project I just mentioned, is Austin Becker is the PI of that project. Happy to put you in touch with any folks if you have questions too. Yeah. All right, so yeah, we'll kind of keep you posted. We'll keep Jenny posted on how it goes, but we'll make sure that any work that is done here in Rockland, we're not going to leave you hanging, that it's like useful and to the amount of resources and funding that we're able to bring, but the full suite of what we're hoping to bring through this project and what was planned to bring is being able to, kind of through our team, we want to make sure that all these academic priorities are really aligned with and responsive to your local community needs and what you already have planned. We're able to bring in staffing capacity to support coordinating those projects, broad community engagement, engaging with middle and high school teachers, bringing curriculum in, talk about some of the social science, kind of perceptions of place and influencing on decision-making, coastal flood community science, the water level sensor that'll go on the pier, as well as there's another type of sensor that's being developed. We call that one the overland sensor. So remember we looked at that photo of Snow Marine Park and like extreme precipitation flooding. These sensors will be able to be placed over areas that flood during extreme precipitation events or inland flood events. And they'll be able to like sense immediately once water starts to pool there, as well as the depth of it over time and when the water dissipates. So we can understand the inland flooding issue. And then that data will be accessible to the public as well, so it will be live. The CHAMP model, which I chatted about, which is that asset level and emergency management response, as well as bringing in that kind of health and well-being component, thinking about today's demographic, as well as what are the trends in changing demographics here in Rockland, and what future demographics do we need to be planning for based off of those like climate issues too. So if it's an aging population, how do we ensure that, or a growing aging population, ensure that we're also taking that into consideration with climate change as well. Yeah, and then also you're part of this network, so there's some opportunity to learn and share with Bath as well as with Providence and Galilee. So we'll be kind of building the connections between those communities. All right, I'm going to pass things over to Evan. I know we're running kind of short on time, just to chat about some upcoming events.
Okay, I'll be brief. Yeah, so we have a few event programming that we like to put on to increase engagement, specifically within the Coastal Flooding Community Science Project around times where we are in the high water seasons. So in a couple weeks, we're putting on this midnight flooding and art crawl event in Portland, where we're going to be traveling around, well, the reason being that all the flooding that's projected to happen this spring's high water season will be happening at nighttime. So we want to provide an opportunity to still collect that data. So we're going to be doing a midnight flood/art crawl, going from site to site in Portland, collecting the flood data, and then also installing and photographing artwork by local artists at the floodwaters to just bring light to these climate hazards. And then, so that's just kind of an example of the programming that we do for this project in general. And during the fall high water season, we'll have similar stuff going on, especially at the end of November and the end of beginning of November and beginning of December. If you're interested in the programming that we're putting on, definitely sign up for our newsletter over here. Or if you're on Zoom, feel free to drop your email in the chat and we can do that for you. And then I'd like to end here with this quote, but maybe first I'll pass it to Jenny from City of Rockland Sustainability to talk about this waterfront project. Yeah.
Hi, everybody. My name is Jenny. I'm the Sustainability and Community Development Coordinator for the City of Rockland. I'm in the Economic and Community Development Department. This is all great. So one thing to note with these is these signs will be going up at those 7 locations. And if you're ever on a walk and there's some like sunny day flooding, or there's a big storm like we had in January and you're one of the people that went out storm watching, please definitely add this data. It's really, really useful to the municipality to be able to see photos of these floods, understand how people feel about these floods, and understand the impacts of these flood events. Also, just a quick note, if you're not already familiar with it, the city has been engaged in a planning process for many years now to redevelop Rockland's downtown waterfront. This is Harbor Park and Bowie Park, including the public landing, the harbor master's office, Middle Pier, basically where where the Lobster Festival is. So the planning is done, the design is done, permitting is underway, and funding was just secured for Middle Pier and Bowie Park redevelopment. So that's very exciting. This part of the plan is funded and secured. So that will be redeveloped in the future, the near future. We don't have a groundbreaking date yet, but just a very exciting note for us, yeah.
Did the sewage treatment plant get flooded during the event?
No. So the sewer treatment plant, we actually with EPSCoR or with 3CRS looked at the sewer treatment plant because it is such critical infrastructure. It wasn't flooded in 2024 storms. However, the pump stations are particularly vulnerable. There's a pump station at Bowie Park, at Sandy Beach, and there's more that I'm not recalling.
I always think about after there's a hurricane or flood,
Sure.
about pollution that you don't even think about.
Right. So that is something that is of concern for Rockland. We just finished a stormwater master plan, which addresses our combined sewer overflow infrastructure. Rockland has pretty aging sewer and stormwater infrastructure. What this means is that our sewer lines in many places in Rockland are combined with our stormwater lines. So during these severe precipitation events, what can happen is, it doesn't always happen, but what can happen when things get really bad is all of the stormwater that goes into the storm drains mixes with the sewer water. It overwhelms our wastewater treatment plant because it's way higher volume than what we're used to dealing with. And then that can cause issues with whether or not we're able to complete primary, secondary, tertiary treatment. So there's no untreated sewage going into the harbor, but sometimes those like tertiary treatments get bypassed. So it's definitely of concern.
I live here, you ever
Oh, well, where? In Vermont. So I lived in Burlington for a while. Yeah. Oh, yeah. Yeah. Mm-hmm. Yes. That's what we're doing as well. So our stormwater master plan addressed all of our stormwater infrastructure and how and where to divide it. I mean, it needs to be divided everywhere. Combined sewer isn't allowable anymore. Yes, like bioswales and green infrastructure. So that's also in the plan. It's a great plan. Right, Pierce did it for us. So there's like green infrastructure components, Ralph Elmer Square, which is that little triangle near Dunkin' Donuts. That has a planned green infrastructure piece, which is basically a big vegetated catchment. So instead of water going into the storm drain and immediately, what happens in that particular section is when it's raining out really hard, there's a storm drain that just drains directly onto that low-lying floodplain below where all of the boat storage is. And so that is really at risk of flooding. And one way to help reduce that is by creating, it's basically a catch basin, but it's vegetated. So then water can be held there and then recharge the groundwater instead of just going straight out to the harbor. So there's that. There's a bunch, I mean, it is a comprehensive plan. And then also like Winter Street, if you know how there's like benches and really nice streetscaping there now, that was part of a combined sewer overflow sewer separation project. So when they separated that sewer, they also added in new streetscaping components to make the street a little bit nicer. And the same thing is planned for Oak Street now. So making progress. Anything else? Yeah. I'm always happy to get in touch. I didn't bring any cards today. I'm very sorry, but you can find me online. Yeah. Yes, it is. It's on the city's website, which is hard to navigate. We're getting a new website any day now. It's going to launch. So that'll also, lots planned. Yeah, okay, great. Good to talk to you all. And thank you.
Yeah, thank you so much, Jenny. And I'll just finish off reading this quote because talking about and thinking about climate change and plans for the future can be so stressful, but this quote brings me some hope. It's from Dr. Ayanna Elizabeth Johnson, and it says, "To see beyond what despair sees, to move from the feeling toward the possibility, calls for things we have in abundance, love, imagination, and a willingness to simply tend the world as best we can without guarantee of success." So thank you all so much for your time, and we'd be happy to take any questions.
Sir, this gentleman here, you mentioned an acronym about the yeah. I heard there's a chance it could collapse.
Yes, it has before,
Okay,
a few times.
but like tens of thousands of years ago.
Yes. Most recent one may have been in the 1600s. Slight deviation. Really showed Western Europe a bit. The major break probably was when they back to Sweden break out to St. Lawrence, broke it after 1,000 years. Yeah, it happened.
And does this factor into anything you guys are working on with this plan?
It's in their fear factor list.
Yeah, well, I don't know, I might actually point things over to Sarah, who has an oceanography background, but you're off the clock. Oh, you do as well? Okay, great. We just hired at GMRI a physical oceanographer, so like really diving into that space. We had a physical oceanographer, but he is now retired in Rockport. So working on their climate commission, Jeff Runge there. So we're kind of just bringing that capacity back on staff with a kind of climate outlook. So yeah, it's definitely a place that we'll be moving into towards with research and understanding those repercussions here in the Gulf of Maine.
So you mentioned the word climate many times.
Yeah.
And today, there were some news stories about how the Trump administration has been going into existing websites and clearing climate resources with climate in it. Does this happen to anything you guys have been involved in?
Yeah, great question. I have avoided the news today. We've been able to be enjoying the sunny day here in Rockland. So yeah, we're a nonprofit, nonpartisan organization. So what lives on our website is ours and untouchable by that. Some ways that we are, that said, we do rely on federal funding. I think right now it's about 40% of our organization's budget. So we're like currently exploring ways to diversify our funding away from federal, even more so, but also a little bit of like how do we also still access those funds without using the long list of terms that are no longer acceptable by federal funds. And a lot of that, yeah, comes down to like disaster preparedness instead of climate change, or yeah, flooding instead of sea level rise. So it's a lot of rephrase, but it was part of how federal funds were received in 2016 to 2020. So Yep, doing it again. Mhm.
Any questions from online at all?
No, great. I'm just like so excited about the expertise that's clearly in-house. And like great to see so many folks that are out and engaged and wanting to engage and learn more about this work. And yeah, as Evan said, if you want to kind of stay in touch with the work that we'll be continuing to doing in partnership with the City of Rockland, please make sure we've got your email, and we'll let you know about future events and opportunities to engage in that. But yeah, thank you so much for your time and 10 extra minutes as well. So appreciate that. Thank you.